Hello, and welcome to Set It and Forget It, the autoscaling webinar where you'll learn about our new target tracking scaling policies. My name is Andre Dufour. I'm a senior manager at AWS and a friend of autoscaling. Our intent in today's webinar is for you to learn about two broad topics. Firstly, what is autoscaling and when might you use it? And secondly, and more specifically, we'd like to teach you about our new target tracking scaling policies, how you might apply them, and what best practices we recommend. Now, autoscaling use cases divide into two broad categories: fleet management and dynamic scaling. And fleet management is a rather interesting use case. Many people don't actually know that autoscaling can do this. Fleet management makes the process of bringing instances into service fully automatic. It allows you to specify the properties of the instances to be launched, including custom launch workflows. It automatically balances your EC2 capacity across availability zones, so you have resilience to localized failures, and it automatically monitors and replaces unhealthy instances. So in this particular example on the left, we have 3 EC2 instances. Autoscaling has automatically brought these into service, ensured that they were healthy, and placed them behind our elastic load balancer. Now imagine one of these instances were to become unhealthy. Ordinarily, this would require you to take a manual action to detect the failure and replace the instance yourself. But autoscaling has the ability to detect this on your behalf, terminate the unhealthy instance, and commission and bring into service brand new healthy capacity in exactly the same image as your other EC2 instances in the autoscaling group. Now, although our topic today is going to focus much more on target tracking scaling policies, I thought I'd tell you about this nifty feature of autoscaling because it really is an AWS best practice to use this to ensure that your application remains resilient and available. Now on to dynamic scaling, which is a critical feature that allows your application to change its capacity in the face of changing demand. This is what we're going to be really focused on today. So in our example here on the right-hand side, you've got 2 EC2 instances, and they've been placed in an autoscaling group, again, behind an elastic load balancer. And in our example, these are playing the role of an application that is CPU bound. So if we play this forward, we have our CPU utilization that's relatively low and healthy for a period of time, and then it begins to spike, likely as a result of more demand being delivered to the elastic load balancer, which in turn goes to my instances, and on average their CPU increases. Autoscaling automatically detects this, provisions 2 more instances, thus returning the average CPU utilization once the load is spread and things stabilize back down to a healthy level where your application is healthy, performant, and highly available. And if the CPU utilization were to drop because demand on the app is dropping, the additional capacity, or even some of the original capacity, could be removed because it's no longer needed for performance, and therefore you save money. And this is really what dynamic scaling is all about. It's about adjusting your application's capacity in the face of changing demand so that you can optimize amongst availability, performance, and cost. Now, at the end of the day, you want enough capacity around to ensure that your app is available and giving customers the right experience. And in a traditional scenario, that is without autoscaling, this would mean that you have to scale your resources to account for the peak of your demand. So this gives you 2 out of the 3 things. It gives you performance and it gives you availability, assuming you correctly estimated your peak. But it also means that you're paying for peak all the time. And your application might have changing demand. For example, the demand might change throughout the day, or you might have seasonality where your application is only busy towards the end of the month, or maybe even changing demand in response to events that you can't predict, such as your application being featured on TechCrunch or your company being featured on Mad Money and driving a bunch of traffic to your website or to your application. And so this is where dynamic scaling comes into the picture. And when we talk about dynamic scaling, it really comes down to 3 things. What metric is important to your application? Is it CPU bound? Is it memory bound? Is it IO bound, for example? The second thing is what threshold matters for that metric? What is the point beyond which you need to add more capacity to remain available and highly performant? And finally, what will you do when that threshold is breached? Specifically, how much capacity will you add in response to the breach? And so let's make this a little bit more concrete, and it's useful to have a bit of a history lesson here. So we have three different types of scaling policies with autoscaling. The first and simplest is simple scaling policies, and we introduced these back in 2009. So with simple scaling policies, you can pick any CloudWatch metric as your load metric, specify a single threshold beyond which you want to scale, and then specify your response. For example, how many EC2 instances you want to add or take away. And these kind of scaling policies were cool, but customers told us that they wanted to control with a bit more granularity the magnitude of the response as a function of the magnitude or the severity of the threshold breach. So this led us to step scaling policies, which we introduced in 2015. Now these ones still require you to select your CloudWatch metric and specify your thresholds, but you actually have the opportunity to specify several different thresholds along with different responses. For example, you could tell autoscaling that if your CPU is between 50 and 60%, you want to add 2 more instances to bring it back down. And if your CPU utilization is between 60 and 70%, so therefore a more severe breach, add 4 instances so we get the capacity spun up more quickly. So you have the opportunity to define those steps with step scaling policies. So this was much better, but in a sense it actually required customers to know a little bit more than they wanted to. So we think that it's certainly fair to ask you to know if your application is CPU or memory bound, because that's something that you should be expected to know as its architect. And we also think that it's sensible for you to specify the threshold where you're comfortable with that particular metric, because that's the means for you to indicate the trade-off that you're willing to live with between performance and cost. Right? Do you want to run at a higher CPU and potentially lower performance in order to save some money? Or would you like to keep your CPU cooler, scale more aggressively, but potentially pay a little bit more for the privilege? And so this is, again, something that you should indicate. But why should you have to specify in exhaustive detail the actions to take at each threshold breach? Many customers told us that they were ill-equipped to make that assessment, and they would prefer that autoscaling do it for them. And this is really what target tracking scaling policies, which we've only just introduced in 2007, are about. So let's look at this in a bit more detail. With target tracking scaling policies, we've made the whole experience extremely simple. It's really as simple as setting the value on a thermostat, right? If you think about it, if I set the value on the thermostat in this room to be 68 degrees Fahrenheit, if the temperature in the room is cooler than my 68 degrees, the thermostat knows to activate the heater at a certain intensity in order to get my temperature back up to 68. And correspondingly, if my temperature is warmer than 68 degrees, my thermostat knows to activate the air conditioner at a certain fan speed proportional to how much warmer than 68 degrees it is in order to restore the temperature back down to my desired value. Well, target tracking is the same kind of deal. All you have to do is pick the metric that you want to scale on, set the value, and that's it. Autoscaling does the rest, adding and removing capacity in order to keep your metric as close as possible to the target value. Now, the other thing that's cool about target tracking is it's self-optimizing. So what that means is that there's an algorithm that learns how your metric has been changing over time, and using this information, it ensures that over and underscaling, or if you prefer to talk in control systems theory, oscillations, are minimized. And so with this in place, you get the fastest scaling response, since we're continuously calculating how much the capacity should be adjusted up or down based on how far away the actual metric is from your target value. So let's have a look at this in a more concrete example. We have, again, traffic being delivered to an ELB and served by an autoscaling group that currently has 10 EC2 instances in it. And this is a CPU-bound application, and so we're going to set a target for our CPU, in this case, to be 50%. And so at the beginning of our time-based example here, traffic is at a certain level. We can see that the blue line here indicates that our CPU is just below 50%, so we're good. And we've got 10 instances. This is the green line projected on the right-hand axis. Now, as we play the example forward a little bit here, we can see that some more traffic actually started to be delivered to our load balancer. So we're about to get busier. The application in turn is farmed out to, or the added load rather is farmed out to my 10 EC2 instances. And this actually causes their CPU to spike all the way up to 75% in this case. So they're running hotter than the 50% that I configured as my target value. Autoscaling detects this, provisions 5 additional instances, bringing the total to 15 in my autoscaling group, which in turn has the effect of lowering the average CPU in my fleet of EC2 instances back down to the 50%, which had been our target. Now, if traffic were to slack off a little bit, autoscaling would have the ability to detect this and decommission or take out of service some of the additional capacity or even the original capacity in order to bring you back up to a better level of utilization and save you money. So let's talk a little bit about how we might set up target tracking scaling policies. And generally when we're talking about target tracking or really any sort of auto-scaling in a sense, we need to be dealing with horizontally scalable applications. That is, anything where the instances are interchangeable drones, and adding more additional identical instances enables the application to serve a higher level of demand. And there are 2 broad categories of horizontally scalable apps that our customers frequently use in conjunction with target tracking. The first one is load balanced applications, and the second one is batch data processing apps. So we'll talk a bit more in detail about how you would set up your target tracking scaling policies to work well with each of these. So firstly, load balanced applications. So here we're looking at a 3-tiered architecture. We have an elastic load balancer, which is sitting behind an endpoint where users are making requests. And we have a compute layer, which is auto-scaled, so some EC2 capacity within an auto-scaling group. And our data persistence layer is exemplified by DynamoDB in this case. Now, with each of these examples, we're going to go through 2 steps. Firstly, selecting or creating the right metric, and secondly, setting the target value for that metric that we've selected. And so for our load balanced applications, we have 2 recommendations. Firstly, you may wish to select the application load balancer request count per target. Now, this is actually a mouthful that amounts to saying the average number of requests received by each of the instances in your auto-scaling group. And the reason we like this particular metric, if you can manage to use it, is because for web applications, which are an example of load balanced applications, this directly correlates to the traffic that your front end is receiving. Now, you might choose to fall back to average CPU utilization as a load metric. And one reason you might do that is if different requests into your front end engender different types of CPU responses. So for example, if some requests are more expensive to process, then the raw count might not be the most indicative load metric, and you may choose to directly use average CPU utilization. Now, step number 2 is selecting the target for the metric that we've just chosen, and this kind of breaks down into 3 sub-steps. The first thing to consider is if you're using the request count per target, this is a pretty straightforward thing that you can extract. And it basically maps to how many requests each of your instances can handle. And this is usually a setting on IIS or Apache or whatever web server technology you happen to be using that specifies how many concurrent connections the web server can handle. And so, again, the reason we like that metric is it's something you can just directly get by inspecting the configuration. So your target should be no more than this value. If you're using CPU utilization as your metric of choice, you're going to need some empirical evidence. you're going to want to determine the CPU level beyond which you start seeing a performance impact from the point of view of your customers. For example, the latency that they're able to observe if your CPU goes, for example, beyond 70%, right? So figure out what that CPU utilization threshold is and set your target below that. Two additional elements to consider here. Firstly, how quickly do your EC2 instances launch before they can start receiving traffic, right? If your instances take a little while before they can start receiving traffic, then you're going to want to leave yourself enough of a buffer to be able to still serve traffic while the additional instances are being brought into service. This means you need to set your target lower to scale a bit more aggressively. That's how you get a buffer. And the final consideration here is how fast does your traffic ramp? So if you expect fast traffic ramps or large spikes at relatively short notice, once again, you're going to need enough of a buffer to handle the spikes and serve the additional traffic while your new instances are spinning up. Conversely, if you don't expect fast ramp-ups, you have the opportunity to have less of a buffer, which will save you money. Okay, so our next category of applications here is batch data processing applications. And this is a three-tiered architecture, again, where you have a producer that is emitting work. In this case, it's a single EC2 instance. It could be more than that. We've got a buffer in the middle, as exemplified by the Amazon Simple Queue service, which will act sort of as an impedance matcher between our producer and our consumer layer, because they may be going at different rates. And then on the bottom is the consumer layer, in this case, a set of EC2 instances in an auto-scaling group. And a real-world use case would be, for example, taking financial transactions, so that's what the producer is creating, and then transforming those into accounting records at the consumer layer. And the rationale for why you might want your consumer layer to be auto-scaled in this particular case is you may have a time-bound SLA. Your application may say, from the moment you give me work, from the moment you put it in the queue, I will process it, I will do my job and transform your transaction into an accounting record in no more than 10 seconds, for example. And of course, because your producer can be going at a different rate, your consumer needs to scale out and scale in order to keep that SLA. All right, so step one, and this is a bit more involved than the previous example, just to give you an idea of some of the things that you can do if you want to get fancier. So step one, instead of selecting a metric, we're going to create a custom metric. So you actually have the opportunity to emit a metric to CloudWatch of your own creation. And so in this case, our metric is going to be called the backlog per capacity unit, which is just the straightforward ratio of the queue size at any given moment to the fleet size. So the number of messages that are hanging out in the queue waiting to be processed divided by the number of instances in my auto-scaling group. So then step number two, as with the previous example, we will now set a target for our custom metric. So this will be the acceptable backlog per capacity unit. And this is the ratio of the acceptable message processing latency, or your SLA, divided by the average time that's necessary to process a message. It's a bit easier to understand this with an example. So supposing your application guarantees a processing SLA of 10 seconds. And you've empirically determined that the processing time per message is 0.1 seconds. This means your acceptable backlog is the ratio of 10 over 0.1, which is 100 messages. And so you will set your target, the target in your target tracking scaling policy, to 100. And so if we continue with our example here, let's say that at a given time, we've still got our target that's 100 messages. Our queue size at this given time is 1,000, and our fleet size, so the number of workers in our auto-scaling group, is 10. This means that the actual value of our scaling metric here is 1,000 divided by 10, which is 100. So my actual is equal to my target. Auto-scaling assesses this and determines that no scaling action is required. Now imagine that we experienced a spike in demand. My producer suddenly got busy, right? I've still got my target of 100, but the queue size has grown to 1,500 because of the work that's being deposited into it at a higher rate. My fleet size is 10. This means that at this particular moment, my actual backlog per capacity unit is 1,500 over 10, which is 150. So my actual value is greater than the target. That means that auto-scaling needs to take a scaling action. In this particular case, it knows to add 5 instances. So once the 5 additional instances are brought into service, bringing my fleet size to 15, you can see that the actual backlog per capacity unit is returned to the value of 100. It's 1,500 over 15. And so my target is equal to the actual value, and no scaling action is required. So let's take the opportunity to talk about a couple of best practices that you can use as you get started with auto-scaling and target tracking. So firstly, setting the minimum and maximum size of your auto-scaling group. This is something you will likely want to do. Auto-scaling, sometimes it makes people nervous because they see it as this black box that potentially is going to take away all their capacity, or maybe add a whole bunch of capacity all at once and present them with a giant AWS bill. Well, setting the min and max give you confidence that this will not happen. So these are as the name implies, the minimum and maximum number of instances that will be provisioned in your auto-scaling group, irrespective of the actual value of your load metric. And so for the minimum, we actually recommend that you set this value to the number of availability zones that exist in the region where your auto-scaling group is being deployed. Here's why. Auto-scaling actually balances your capacity evenly across availability zones. And so if you have as many instances as availability zones, you know that you've got at least a little bit of your capacity in each AZ, and that way you're resilient to any sort of localized failure. So you should set that as your min. And then on the maximum, well, there are a couple of inputs here. Firstly, you will want to perform a load test to determine the capacity that you realistically could need at the peak of demand. See how many requests per second your instances can handle, and how many, basically how much work you want to be able to do at peak, or you expect to do at peak. And the second thing to think about is how much you're actually willing to pay. Is there a maximum amount of cost that you're willing to incur for this application? And that even if demand kind of goes beyond a certain level, you're not willing to pay a penny more, potentially at the risk of reduced performance or availability. This value, if it does exist, will also be an input to your maximum auto-scaling group size. Now, another thing to think about is the fact that EC2 instances don't come into service just instantly, right? They take a certain amount of time. And if you have an application, for example, that requires downloading a whole bunch of data and maybe setting up a little bit of state before it's able to usefully process traffic for you, let's say that takes you 30 minutes from the moment you've decided to launch the instance and the time when it's actually ready to serve traffic. Well, because target tracking scaling policies are reactive, you're always going to be 30 minutes behind demand. And so for this, you have two strategies. The first one is to set a large buffer, as we talked about. Set your value a little bit lower so that you scale out more aggressively. And the second thing that you can do is use scheduled scaling. And this only works, of course, if you have a predictable load. So imagine that your application, for example, you know that every morning at 9 a.m. you're going to get busy as people come into the office and start to place demand on the application. And you know that your instances take 30 minutes to come into service. Set a scheduled scaling policy to scale out at 8:30 every morning. That way, by the time 9 a.m. rolls around, you've got capacity that's available and ready to serve traffic. And you can use this in conjunction with target tracking scaling policies as well. So it's a way to just kind of get a bit ahead of the demand, and then you can follow the demand curve using target tracking. It also works on a one-off basis. So for example, if you know that you have a one-time big event like a marketing campaign that's going to drive a lot of traffic to your application, you can set a one-time scaling event to scale out just in advance of the event and scale back in afterwards. So 3 things to consider when you're dealing with dynamic scaling and your first onboarding. Firstly, we recommend that you analyze historical trends for 2 reasons. Firstly, this helps you determine if there's seasonality or regular traffic patterns, because that will help you set up your scheduled scaling policies that we just talked about. Secondly, it'll help you determine how fast your demand changes or how quickly your traffic spikes so that you can know at what level to set your buffers. The next thing to do is to choose the lower end of your ranges as you're kind of doing your empirical testing. What I mean by this is set your scaling policies to scale out sooner rather than later and scale in rather conservatively. You're biasing towards availability in this case. And then finally, watch and learn and make changes iteratively as your application changes and as it matures. So I'm happy to tell you that application autoscaling now supports 5 AWS services beyond the EC2 instances that we've been talking about thus far. These are DynamoDB, EC2 Spot Fleet, ECS, which is the EC2 container service, Elastic MapReduce, and AppStream 2.0. And with all of these, you get the same basic experience as with EC2, where you're paying only for what you need while maximizing the availability and performance of your application. So with that, I'm going to switch into a demo and share my screen with you. Okay, so here we are in our US East 1 region, and we've got a single EC2 instance. It's just out there in the wild. No auto-scaling associated with it yet. And what I'd like to do is just quickly show you how you can create an auto-scaling group based on this instance, and then we're going to go ahead and set up a target tracking scaling policy. So really the fastest way to create an auto-scaling group is just to start with your existing instance, right-click on it, go to the instance settings area, and say attach to auto-scaling group. I'm going to say create a new auto-scaling group, give it a name, and say attach. Now behind the scenes, with just those few clicks, auto-scaling has created an auto-scaling group in the image of the instance that I used as a basis. And if you remember back to the beginning of the webinar where I talked about fleet management and how auto-scaling can look at the instance and make sure it remains healthy and replace it if anything should happen to it, that is already operating. Just with those few simple clicks, I've determined that this instance should be monitored and replaced if it becomes unhealthy. So that was a really simple way to increase the availability of the app. Now let's go have a look at the auto-scaling group that was created here. I'm now in the auto-scaling console. I can see my auto-scaling group up here, and it has a number of details which I can edit. What's particularly interesting kind of at this stage when you're getting started is the desired capacity and the min and max, right? So we said that min is the smallest number of instances that at any time will be present in my auto-scaling group. So I could change that value to 3, for example, and maybe give my auto-scaling group a maximum size of 9, which is corresponding to the maximum amount of money that I'm willing to pay basically for this application. And I'm going to set a desired size of, let's say, 6 instances. And if I were to go ahead and save this, what we would see in a moment if I flip back to the instance screen is that auto-scaling is going to launch basically 5 more instances to bring my size up to 6. Now let's have a look at scaling policies. So if we go ahead and add a policy here, policy takes a name and a metric type. So we talked about selecting the metric that's of interest for our application, right? So for the load balanced ones, application load balancer request count per target is a nice one. I'm just going to go with CPU utilization. and I can give it a target value of, let's say, 50%. And that's basically all I need to do to create a scaling policy. And so now I've got my auto-scaling group, I've got its scaling policy attached, and that's how you can get going in a few simple clicks with target tracking scaling policies. Let's switch back to the main presentation. So that concludes the prepared portion of this presentation. And with that, let's go ahead and do a couple of questions. Our first question here is from Susan, and she asks, how do I choose between step and target tracking scaling policies? Yeah, it's a good question, Susan. So here's the way that I would think about it. If you want a completely automated set it and forget it experience where you don't have to worry about doing the calculations of how much capacity you want to add and remove when an alarm breaches, we'd recommend that you use target tracking. Customers who are using it tend to love this experience, and I guess I would say if you don't have a reason not to use target tracking, you should use target tracking. And one reason why you might choose to go a different way is if you really want to have granular control over how you scale out and scale in, and you'd like to manually tune your scaling policies, then you're certainly free to use step scaling policies, and that will work well for you as well. Now, our second question is from Ling, and she asks, how does target tracking determine how many instances to add or remove? Yeah, it's a good question. So target tracking actually adds or removes instances in proportion to how much the actual value of the metric you're scaling on is distant from your desired target, right? So think back to our thermostat example. If it's like much, much hotter than the value that I'd set, then we're going to have air conditioning on full blast. Whereas if we're only a little bit away, then it's going to be a more moderate response. It's the same sort of deal with target tracking. And so a few of the really great features about target tracking are that during scale-in, so when we're removing capacity, target tracking removes instances more conservatively and gradually, so that if you happen to have a sudden down spike in traffic only for a limited amount of time, it would not remove all your capacity or a lot of capacity, and it would prevent underscaling. Also, target tracking actually has the ability to determine what's called the dead zone, right? This is a bit sort of control theory, but if you think about step scaling policies, you wind up having two thresholds, one for scale out and one for scale in. And the idea is to have a band, sort of range basically of values where you don't oscillate. With target tracking, it automatically finds that band for you. So it learns the behavior of your application and how your traffic is varying over time, determines the dead zone to prevent oscillation, and keeps your metric as close as possible to the target. Our next question is from Andy, and he asks, what if I want to use target tracking only for scaling out? Yeah, this is one that sometimes comes up where people want to be a little bit more conservative on their scale in. They're happy to scale out automatically, but scale in, people are kind of cautious and they want to manage it manually. And that's something that you can do. There's actually a setting where you can disable scale in. And in that case, target tracking will basically monotonically grow and won't be taking away capacity unless you explicitly decide that that's what you want to do. I just wanted to point out that we would love to hear from you. If you have really cool examples of things where you're using target tracking scaling policies, or even just any kind of neat auto-scaling applications, why don't you go ahead and share them with us on Twitter using #smoothscaling. And if you'd like to get in touch with me personally, I've given you my Twitter handle at the bottom here.